Hello, and welcome to the third and final part of Lesson 8-7, which we're still dealing with exponential functions, but today we're actually going to be looking at writing a model given a set of data or some data points, and we're going to learn how to put that into an actual equation. So we will start right off with example number 7, where it says to write an equation to model the data that's given. So if you recall from parts 1 and 2, an exponential model is written in the form of y equals a times b to the power of x. So when I look at this data table over here, okay, one thing I want you to pay close attention to is notice that my x values are going up in increments of 1. If we go up in increments of 1, we can just kind of plug things in and everything's going to work out nicely. If they don't go up by increments of 1, I will show you what to do here in a couple examples. But for right now, because all of these go up by increments of 1, things are going to work out real nice. What we're going to do is we are going to pick one of the data points from the table. I particularly prefer to choose something that doesn't have a 0 in it for x, but you can pick what you want. So maybe I'll do, we'll pick this one here, the point 112. And all I'm going to do is I'm going to plug in what I know. So from that data point, I know that y is going to be 12. My a value I don't know. Likewise, my b value I don't think I know, but remember b is going to be that constant ratio. So if I come over here to the side and I try to figure out what my constant ratio is between all of these points, I can say 12 divided by 4 is 3. 36 divided by 12 is 3. 108 divided by 36 is 3. So I can actually find that my b value really is 3. Then what I'm going to do is I'm going to raise this to the power of x. Well, because I used my y value of 12, I can see that my x value that corresponds with the y value of 12 is really going to be 1. So now if I simplify this, I have 12 equals a times 3 to the first power is just 3. And if I want to solve for a now, all I have to do is divide both sides by 3. And I can see that my a value is going to equal 4. So if I go to rewrite my equation now, I have y equals a, which I just found to be 4. My b value from these over here we found to be 3. And I'm going to raise this to the power of x. Now, if I were you, I would always go back and double check my work. So if we pick another point, let's just pick the point 236. If I plug that 2 in for x, so I have 4 times 3 to the second power, I hope I get 36 if I did this correctly. So 3 squared is going to give me 9. And then I have to multiply that by 4, which is 36, and that's exactly what I should have gotten. So you can try this for a couple more points if you want to, just to make sure you are on the right track. But that's how we do it if our increments, again, and our x values go up by 1. Okay, example 8 is very similar to example 7. Again, I'm going to look at my x values. They do go up in increments of 1. So I can come over here and I can solve for my b value then. Negative 10 divided by negative 2 is a positive 5. Negative 50 divided by negative 10 is also a positive 5. So I now know that of my y equals a times b to the power of x, I know that my b value is going to at least be a 5. Okay, so I've got this much information figured out. So now what I'm going to do is I'm just going to go pick another point. And again, I'm going to use the point 1, negative 10 and plug in what I know. So negative 10 is my y equals my a times 5 to the power of 1. This really gives me negative 10 equals a times 5. And if I divide both sides by 5, I can see that a then is going to be a negative 2. So now I have y equals a negative 2 times my b value, which was 5, and we'll raise that to the power of x. And now I have my exponential function written. And again, I highly encourage that you double check your work. So without writing it down, if I plug in the point 2 for x, 5 squared is going to give me 25, and 25 times a negative 2 will give me the negative 50 that this point predicts. So that means we're probably on the right track. So let's go ahead and look at example number 9. Example number 9 is going to be slightly different because if I look at my x values do not increase by increments of 1. Here they're going up by increments of 2. So we can't just go ahead and divide these out because my y values aren't going up by a constant rate. So I have to calculate what that rate is based on the increments that I'm jumping in my x values. So for this example, what we're going to do is we are going to actually write out everything we know, and we're going to have to create 2 equations, and we're going to do a ratio of 2 equations. So what I mean by that is, let me pick my pen here. I'm going to start out, and I'm going to use this point here, which is 4/160, and the point 240. Now, just like when we calculate the ratios, we have to take a later term and divide it by a previous term. So what I'm going to do is I'm going to plug in the values that I know, and again we have our y equals a times b to the power of x, and the x doesn't want to write there. There we go. Okay, so when I write this out, and again I'm going to start with the later term and divide it by the previous term just like we would for a normal ratio value. So if I plug my 160 in for my y, I don't know what my a is, and I do not know what my b is, but I know what the exponent is on b, and that's going to be this 4. And then I'm going to divide that by, and I'm going to do the exact same thing now with this point. So my y value is 40 equals a times b, and my x value is 2. So if you notice now, what's going to happen is when I go to divide these out, 160 divided by 40 is going to give me 4. So I get 4 equals, my a's are going to cancel out because a divided by a is going to give me 1. And then I have b to the 4th divided by b squared, which is going to give me b to the, when I divide, remember we subtract, so it's 4 minus 2, or 2. So now I have b squared equals 4. If I want to undo the square, I have to square root both sides. So now I'm left with b equals 2. Now that I know that b is equal to 2, I can go ahead and write my equation as y equals, I still don't know what a is, but I know b is 2, and that's going to be raised to the power of x. So now what I'm going to do is I'm just going to pick one of my values, okay, from my table, and in this case I'm going to pick the 6 and 640 and just plug those in. Again, it can be any point from that table. So I know now that my y value is 640 equals a times 2, and my x value for 640 was 6. So this is going to give me 640 equals a times 2 to the 6th power is actually 64. So now if I want to go ahead and solve for a, I'm just going to divide both sides by 64. My 64s will cancel here, and I'm left with a is equal to 10. So now I know what a is. I can rewrite my equation as y equals 10 times my b value, which we said was 2, raised to the power of x. And now I have my equation. Again, though, I would highly suggest that you go back and double check and pick a point. Even if you pick like a small number that we've already used, something like 240, if I go 2 to the 2nd power, that's 4 times 10, that would give me the 40 that I have right there. So it looks like we're on the right track. Another format that you might see these types of problems in are just like in coordinate points. So again, if your points are in consecutive x value order, then we are going to have to do the same thing that we did back in example 9. So if we look at example 10 here, and we look at this first one, I see that 3 for my x value I jump from 3 and I then go to 6. So these are not in consecutive order. So I am going to have to sit there and do the ratios. So I end up with 2,916 equals A times B to the power of 6 is my x value. And I'm going to divide that by 108 equals A times B to the power of 3. When I simplify that, 2,916 divided by 108 is going to give me 27 equals, my A's cancel out, and I end up with B to the 6th divided by B to the 3rd is going to give me B to the 3rd. So in my head, I say, what number can I raise to the 3rd power to get 27? And that number then is going to give me B, and that would be 3, because 3 to the 3rd power gives me 27. Now that I have my B value, I can rewrite my equation. So I've got y equals A times B, which is 3, to the power of x. And I'm just going to pick one of these coordinate points, which in this case I'm going to pick the first one and plug in what I know. So I have 108 equals A times 3, and my x value in this case is 3. So 108 equals A times 27. If I divide both sides by 27, this tells me then that A is going to equal 4. So now I can write my equation as y equals A, which I found to be 4, times B, which is 3, raised to the power of x. And this is my final answer then. At this point, I would encourage you to try to do this last point on your own by pausing the video. Otherwise, I'm just going to go ahead and work right through it. And we're going to do the exact same thing that we did before, because I see that my x values are not consecutive. So I'm going to have to set up that ratio. So to do that, I have my y value, which is a negative 20.25, equals A times B to the power of x, which in this case is 2. And I'm going to divide that by a negative 0.25 equals A times my power of 0, or A times B to the power of 0, sorry. And so when I simplify that, a negative 20.25 divided by a negative 0.25 is going to give me 81. My A's are going to cancel, and I have B squared divided by B to the power of 0. So I have B to the 2 minus 0, or B squared. So again, if I square root both sides, then I see that B is going to give me 9. So now I have y equals A times B, which is 9, to the power of x. So now I'm just going to pick one of those points and solve for my A value. And I'm going to pick the first one because 0 is a nice, easy number to work with. So if I plug in what I know that I have a negative 0.25 equals my A value, which is still unknown, times 9 raised to the power of, in this case, it's 0. Anything raised to the power of 0 I know is just going to give me 1. So I really have a negative 0.25 equals A. So I don't have to do any further work unless you want to divide by 1. But now all I have to do is rewrite my equation as y equals A, which is a negative 1/4 or a negative 0.25, times our B value, which is 9, raised to the power of x. So this will conclude our video. If you have any questions, please do not hesitate to let me know. Otherwise, have a good afternoon. Thanks.